How do we know that it's a sustainable industrial system? Normally, there are three types of industrial ecosystems. You have the linear, the quasi-cyclic, and cyclic. Again, the objective of industrial ecology is to optimize the total materials in such a way that you form a cyclic or a cycle. So that means for industrial ecology, we are promoting cyclic industrial ecosystem that is an ideal system with zero material inputs and outputs. So here we're talking about resources such as the raw materials, the energy, as well as the capital. And it is vividly shown in this figure. So you have the resources, you have the ecosystem or the environment, but we introduce the other sphere, which is technosphere. And the waste that would be generated from this industrial ecosystem would now go to the environment and supposed to be, it should be converted back to resources. So that is an ideal industrial ecosystem. After discussing the science of sustainable development, which is industrial ecology, we'll try to discuss one of its tools, which we call life cycle analysis. This is commonly used in the industry, that's why we will focus on this tool. In this tool, the engineering design process is applied. So basically, in engineering design process, you identify the need, the problem, the demand, and the load. And then you identify, specify, select, and evaluate the resources that you utilize in the process. And then your objective is to come up with optimal solution. Actually, we are teaching you already how to do it using engineering problem solving in design, or what we call analytic approach, when we ask you to solve a particular mathematical problem. So take a look at this engineering problem solving and design approach, which is actually the analytical approach. When you do compartmentalizing, you actually solve the problem by identifying the given. You're familiar with this? So you identify the given, you compartmentalize by using a system wherein you identify the data that you have as your inputs, and then you have your outputs. So this is system under study. So all the data are actually being focused and compartmentalized. The next step in mathematical problem solving is identify the required. So that is actually identifying your problem. And then next would be you solve the problem. In solving the problem, the first thing you need to put in your solution is what? The equation, right? So when you identify the equation, you're actually identifying the variables. And from here, you can continue solving the solution by identifying your basis and some of your assumptions. By doing so, you're actually applying the boundaries and framework identification. And then, of course, you're supposed to come up with clear solution. Clear and exact solution. So this is the analytic approach. Now, the reason why we apply this approach are for these purposes. So number one, you want to comply with the regulations. And then, of course, the main objective of any business is to increase energy efficiency. And you also have to identify the material that you're going to make use of. And sometimes you apply the materialization in order to increase productivity but lessening the operational cost. And then, of course, our main objective in industrial ecology is to come up with an optimal design. This is actually your cyclic industrial ecosystem. And therefore, we emphasize a design for reuse and recycling. We also would like to do modularity approach in such a way that we can contain the inputs and the outputs in a particular industrial system. And then sometimes we also implement interchangeability of the components so as to come up with optimal solution. Now, before LCA comes into the picture, the most commonly used and actually considered as the well-developed field is your pollution prevention, or what we know as P2. This focuses on design of industrial processes to eliminate waste. And it has been proven success with cleaner technologies, and it applies the inverted pyramid principle. This is actually considered to be the P2 strategies. So it's an inverted pyramid approach because we give more emphasis on this portion, and then as we go from top to bottom, we consider this as the less desirable. That means as engineers, the least that you should do for a particular product after utilization of it should be the disposal. And of course, since there's no such thing as forever utilization of resources, prior to disposal, you should consider also treatment. But as I have mentioned, the inverted pyramid approach gives more emphasis on source reduction. So instead of recycling, we first go to the main root of the problem, that is actually lessening the generation of waste.